Good morning, students. Welcome back to the class. Yesterday we discussed that the calculation of the electrode potential of the cell, or we can say the EMF of the cell. Fine, and we made the cell by the combination of the different electrodes, zinc, copper, silver, etc. You can make many of the combination, and we can find out the EMF of the different type of the cells. Now today, the question comes that yesterday we have taken that some values of the ER and EL. That is, if you say that if zinc is converted into zinc ion, zinc 2 plus ion, the value was electrode potential value was minus 0.74, sorry, 0.76, and for the copper it was 0.34, right? So that individually, how do you calculate these values? This is the question. Like individually, zinc is having this much of value, and the copper is having this much of value, and silver is having this much of the value, fluorine, chlorine, bromine, iodine, etc. Any other element you can take, then what will be the electrode potential value? So how did you calculate this electrode potential value? So the question is that how did you calculate these values of these individual metals or the non-metals? So for this purpose, we are introducing the new thing. Is it fine? That is called measurement of the electrode potential of the individual half cell. Fine. So this is the topic for today, and in this method we can find out that how the values are there, how the values can be detected of the individual element. Is it clear? So for the calculation of this one, measurement of the electrode potential, we have designed a type of the cell. This is called as a reference electrode, or it is also known as a standard hydrogen electrode. It has its own potential 0. Its own electrode potential will be 0. So with reference to the 0, we need to find out the individual value of the individual elements. Is it fine? So the design of this is a standard hydrogen electrode is, it consists of a beaker. Is it fine? In the beaker we'll take the 1 mole of the acid. 1 mole of any acid can be taken. It provides the H plus ion. Now inside it you will see that a test tube like structure is there, which is open from this side. Is it clear? So in that there is a platinum finely divided by the platinum coated or the platinum foil. The platinum coat is there, okay, and this is the hole made up of from the platinum. So it's a kind of the a cube which is inserted in that, and which is having a platinum, and the platinum wire is there which is coming out of it. Is it clear? Now here you will see there is a space present in them. This space here, you can see that there is a space in this. Space is filled with the hydrogen, and this hydrogen will be at the 1 bar. The pressure of the hydrogen will be at the 1 bar. So here you will see that this is the setup of the standard hydrogen electrode. Is it clear? So, and this is also known as a She. In the short form it can be called as a She, right? So what type of the reaction is taking place in that? You will see that when hydrogen will gain 1 electron, then it will be converted into the hydrogen. Is it fine? From where the hydrogen ions are, the hydrogen ions are present in the acid. Is it clear? And the electrons will be given by either zinc or the any other electrode which is connected to that. Is it? When this electron will come to the hydrogen, it will be converted to hydrogen gas, and this hydrogen gas will be bubbled out through the solution. Is it clear? And the electrode potential of this She can be denoted by this method. E naught is equal to, E naught PT, H2 is converting into the H plus, or sometimes instead of the hydrogen we can use the bromine also. So for this, if you are using the bromine, then it will be E naught PT oblique Br2 or Br. So either this one or this one, any of these two can be used for them. The electrode potential of this will also be 0. So by using this She, how will you calculate the electrode potential of the individual's half cell? So first let's see that we know that E naught cell is equal to E naught R and E naught L. Why? Yesterday we used that E only, fine, but today we are using the E naught. So what is that E naught? We just have to find out. E naught means what? This is called standard electrode potential, standard EMF of the cell, and this is the standard electrode potential of the right hand cell, and the standard electrode potential of the left hand. Standard means in the standard conditions. At STP, whatever the values are there, that is called as the standard electrode potential. I hope you all understood this thing. So for individual element, we will calculate the individual thing. So first thing is that if you take zinc, okay, we need to find out the combination of the cell in which the zinc is there. One of the cell is the zinc and another will be the She. Is it fine? She is that standard hydrogen electrode. Then we can find out the electrode potential of the zinc. So how will you connect? So in the left hand side, zinc electrode will be there. Yesterday we have taken one beaker in which zinc sulfate was there. In that, zinc rod was inserted. So one side the zinc half cell is there, and on another side that she is connected. So between them, like in the she part and the another one, that is zinc part, is it clear? So you will see that salt bridge will also be connected and a voltmeter will also be connected. So the representation of the cell will be that zinc is converting Zn2 plus, and this is the salt bridge, and then Pt converting H2 or H plus. So this is the combination of the cell. So now we need to find out the electrode potential of the particular cell or EMF of the particular cell. So E cell is equal to ER minus EL. And you people know that Pt H2 H plus is taken as 0, so I have put toward this side ER because she is in the right hand side. Is it fine? The right hand side means it is the value is 0 minus the voltmeter will show the reading of 0.76. So after putting this value, we can find out the E naught cells value, which will be equal to E Zn in converting into Zn2 plus, that will be minus 0.76 volt. Is it fine, students? So this is for the zinc, and this value will be taken down in the whole table which is given in your book. Now come to the second one, for the copper. Copper is present on the right hand side. Yesterday we have taken that copper was present on the right hand side, so we will connect this Pt towards the left hand side. So left hand side Pt will be there, and on the right hand side the copper will be connected. So here the formula, the same formula will be used. E naught cell is equal to E naught R minus E naught L. So here E naught cell is equal to E naught R. R side is copper. Copper is giving the value of 0.34 voltage in the voltmeter, and the Pt is left hand side, its value will be 0, which I have taken this side. So overall value is 0.34, so this value will be showing in the E naught cell. So E naught cell will be equal to the value of E naught Cu2 plus is converting Cu, that means 0.34 volt. So we can find out that, so individually the electrode potential of the She was 0 and the electrode potential of the zinc was how much? Minus 0.76. The same way this one platinum, this side that She was 0, and that is copper 2 plus is converted to copper, that will be equal to the 0.34. So individually when we combine these two values, minus 0.76 and 0.34, yesterday we have got the value of 1.10 voltage. Is it fine? So we make that electrochemical series. So if you see the electrochemical series, then you will see that lithium will be having the highest value of the negative, that will be minus 3.05 volt. Fine. In the same way, if you talk about the fluorine will be having the maximum positive value, that is what? 2.87. Now you see that if we make a cell of the combination of the lithium and the fluorine, then what will be the value of the potential difference in that? So you need to see that. Is it clear, student? Topic.
Start.
Now, so this was the value of individual electrode. Now we just have to think about the electrochemical cells, right? So what are the electrochemical cells? You see that, you know that yesterday we have seen that this was the zinc, is it fine, and that was a copper, okay, and we connected this with the bulb, right? There was a bulb, is it fine, and bulb was connected to that one, and there was a salt bridge this side. Is it fine? This was the setup we have seen. That bulb was started going. Now I'm doing that. Here it is. Instead of the bulb, if we put what? A battery. Okay, plus and minus. So this is what? E external, or we can say volt external, and this is what? E. EMF of the cell. Is it fine? So we are taking this one. V external, and second one will be the EMF of the cell. Okay, these are the two things. That means what? If the cell is connected to the a battery, an external source of battery. Now, what happens when this this setup is done? If you say that if the value of this external battery is less as compared to the EMF of the cell, then what will happen? Then what you will see that the potential difference of the cell, and that means the EMF of the cell will be more as compared to the external source voltage. Is it clear? So that time what happened? The current will go outside and it will charge the battery. The battery which is connected to this side, this battery will be charged. Why is it so? Because the value of the potential difference value of this thing will be maximum as compared to this one. Maximum is more. Understood? The more the value of the cell, the battery, external battery will be charged. Is it fine? So the condition is that battery will be charged. and the reaction which were taking place, okay, in which what happened, the zinc was donating the electron and copper was gaining the electron, the same reaction will be taking place. That means what, the overall reaction was that Zn plus Cu2 plus, that was converting into the that Zn2 plus Cu. So the reaction was taking place. That means zinc is donating electron and copper ion will be gaining the electron. This is the condition in which this is taking place. Now this was the first condition. Now second condition, if V external is equal to the EMF of the cell, what happens? If V external is equal to the EMF of the cell, then we can say that no net current is flowing. So whatever the current which is going out of this in the battery, the same amount of the current is going back in that. So the cell will be at the equilibrium. The cell will be at the equilibrium. We can say that this is the equilibrium stage. No net current will be obtained, and the reaction will be taking place like this. No overall reaction is there. Is it clear? Is it fine? So in that condition, nothing can be seen. Now third thing is there, beta. Third part is there, in which what happened, E external is greater than EMF of the cell. V external, that means the potential difference of the cell, external cell, will be maximum, more as compared to the EMF of the cell. Then what will happen? Then you will see that this cell will give out of the current, and this current will go in the lower cell. Is it right? That means this cell has to be charged. Understood? So here in this case, the current will flow in the opposite direction. Initially it was from the zinc to the copper ion. Initially this was that electron, and the current was flowing from the copper to the zinc. But in this case what happened, the electron will flow from the copper ion to the zinc again. Is it fine? Or we can say from copper to the zinc 2 plus, right? The electron will go in that way, and the charge will flow in that will be the conventional current from the zinc ion to the copper, and the current will flow in the opposite direction. So whatever the reaction was there, that will be inverted. Inverted means what? Zn2 plus Cu, that will be converted into the Zn plus Cu2 plus. The reaction will be reversed. Understood this thing? So in that condition, when the external source of current will be given to the cell and the reaction will be reversed, is it fine? And the current will also be reversed. In that condition, the certain setup, this setup is called as an electrochemical cell. This setup is called as electrochemical cell. Yeah, we can say that this cell is called as an electrochemical cell. So ultimately we can say that the cell can give out of the electrical energy, and if we give the electrical energy from external source, but the condition is that external source electrical energy's value should be higher as compared to the cell, this cell. So in that condition, the reactions and the current will be reversed to the previous one. Is it fine? In that condition, this is called as a electrochemical cell. I hope you understood this topic. Is it clear? Now these are taking place at the concentration of 1 mole, etc. But if you change the concentration, then different thing will be there. We will discuss in the next part. Is it clear? Okay. Okay. The next part is we have calculated the EMF of the cell. We have calculated the electrode potential of the half cell, like zinc, copper. We can calculate the electrode potential of any other cell. Is it fine? But one condition was there. The condition is there, like what will be the concentration of the zinc sulfate and the copper sulfate in the individual cell. Here we have taken that the concentration of the acid was 1 mole per liter. Fine, but what will be the concentration of the zinc sulfate and the copper sulfate? So here the answer is, beta, like we need to take the concentration as unity. That means 1 mole per liter in both the conditions, both the cells. Like zinc sulfate should be unity, copper sulfate should also be unity. Is it fine, beta? So that should be the concentration of it. And at this unity part, we need to calculate the EMF of the cell and the electrode potential of the cell. Now the question arises, like what if we change the concentration? What happens when we alter the molarity? Is it fine? The molarity means if instead of the 1 mole per liter, if we take 2 mole per liter, 3 mole per liter, and if the concentration in both the cell will be different, in that case what will happen? So here the answer is, if you change the concentration, then the new equation will come, and that new equation is called as a Nernst equation. So our next topic will be the Nernst equation. So this Nernst equation will be responsible for the calculation of the EMF of the cell at even standard condition and at the normal condition. Is it fine? And the concentration will be altered. If you alter the condition, concentration, then you can find out the EMF as well as the standard electrode potential of the cell. Is it fine? So there are two conditions. The one is when the concentration is unity, and the second one is if the concentration is more than unity or less than unity. Is it fine? If unity, then E cell can be calculated by ER minus EL, and if it is not unity, then we can calculate by using the Nernst equation. So we'll discuss the Nernst equation in the next lecture. Is it fine? Because it is a big one. So meanwhile, what you will do, you just go through the book, fine, and just whatever the language is written in that, you need to read all this, because MCQs are based on these lines. So you need to, this is the homework for you, you need to just start making the notes. Is it fine? Once the school will open, I'll see all the notes, and I'll see that whether you have done in the proper way or not. Is it clear, student? So thanks for today, and we'll take the Nernst equation in the next lecture. Okay, have a good day.